Hey there, this is video U6.3, characteristics of linear equations and graphs. So I want to do a little clarification, make sure you know what a linear equation is. And then we're going to start doing we're going to graph some linear equations. When we get all done and really good at that, then we're going to graph linear inequations, which is a couple, 2, 3 more steps. But these are really important, just as knowing how to plot points properly is really important. This chapter, I think almost more than any of them, really just built. If you need more practice on plotting points, you know what, Google it, email me, I'll send you stuff. We can find stuff for you for practice. You got to be good at that before you take the next step. All right, anyway, smile around. We need to review linear equalities before we learn the inequalities, which is what I just said. If it's an equality, first of all, then it must, well, it has to be an equation. And it has to contain, if it's an equality, guess what? It's going to contain an equal sign. Go figure. I was trying to figure out, I got to leave some blanks for you to do so you're not just listening to this little talking head in the corner. All right, all of these here are linear equations. So there's my equal signs. They're equations, they got stuff on both sides. And all the ones over here are not linear equations. Take a couple of minutes and stare intently at them and see if you can tell me the difference. Well, actually, I'm going to start right here because you know what? That is not a linear equation. Why? It doesn't have an equal sign. Exactly. That's actually just a point. All right. All of these over here, if you look, you've got powers going on. So nonlinear equations have exponents, or there's a couple weird things here. Multiplying or dividing. Oh, that's going to look like an X. You're not going to know what that meant later. Or all right. The key thing over here, because this is the stuff we care about, linear equations, you know what? They don't have any powers. No exponents. And they've usually got at least one variable. "95% of the time, the stuff we're going to do is going to have x's and y's, both of them in it. But you can have some simple ones. Oopsies. Right, guess I'm going to start using pen because my pencil keeps breaking. All right, sorry. Ones like that, where you just have the one variable. For what it's worth, x over 2 plus y equals 16. That would be a linear equation, right? Because I said over here, there could be multiplying and dividing, but it's the two variables that are being multiplied together, or this is x divided by y. If you're dividing by a number or something, that's okay. It doesn't matter, or multiplying by a number. You can even have x. We're not, that's 32, not 3z. Well, it could be 3z. We're not limited to two variables. Just wait until you guys take calculus, or I don't know if you get it in BA math or not. When you start talking about 3 dimensions, this is the horizontal, the vertical, and the coming out of the page. I think that's how it works. It doesn't matter whether it's 3-dimension drawing, then you have X, Y, and Z axes. Kind of cool stuff. Okay, excuse me. Key thing here. Let me get my highlighter. This is, oh, I shouldn't say this on video, but I really don't care what you got taught by other teachers. In my class, you need 3 points to get a line. There's students who are, oh, I'm just going to use 2 because that's really all I need. And you know what? Sometimes they do well, but sometimes they screw up royally and they don't know. So my rule, minimum 3 points. Sometimes if I mess up and I can't find my mistake, I will just plot a 4th point and that solves all my problems. Okay, so here we have a lovely, a lovely box with a star in it. Okay, I'm going to draw a point. You can do anywhere you want. That looks just fine. And you know what? You can put it there, there. I don't care. Just put a point in there. If you're having fun, have one of your children come in and draw a point. Now, can you connect it to the star with a straight line? Yeah. Woohoo. All right. Now I'm going to draw another star, little. Oh, I'm going to draw a triangle because I want to. Right over there. Now, can you connect that to the star? Not to that one, but to the star with straight line. Yes, of course you can. You're like, why is she teaching us? She's not even teaching us. I knew that. I know. But my point is any 2 points can be connected with a straight line. So if this is one of the points on my line, I don't know if this is correct. If all I have is this much, I don't know if that's the right line or not, because any point, and it doesn't matter if it's this one or this one, or I can draw one over here, right? They're all going to connect to that star in a straight line. Well, I don't know, but now I know that this one, and this one, those, as there's 4 points there, are not on a straight line anymore. Not if you look at them in total. If you look at 2 at a time, of course they're in straight lines. All right, now let's look at this bottom one. Draw a point anywhere in the box. And put it over there. Now, can you connect the stars and the point? No, I can't connect these 2 stars and that guy. So they are not on the same line. Okay, draw a different point. Okay, I'm going to eyeball it and I'm going to make this work because here's my new point. If I put it there, then I can. So my point is 3 points may or may not be on a line. So if I know that this star and this star are correct, right? I'm doing graphing, I know those 2 are correct. Well, this point I know is also correct because it's on the line between them. This one messed up. I plotted it wrong, I did some calculations wrong, I don't know, but it's not on the line. So 3 points all the time. 3, disappearing, 3 points. Please and thank you.